What to say? No signals. Really, same problem. 27 minutes, seconds are gone, no signals. What can I do? No signals. Every day's problem, no signals. What can I say? No signals. What to do? No signals. No video, no audio. Now signals have come. Let us see. Good morning, everybody. Good morning, everybody. Good morning. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India. On this day, August 6, 2021, Friday, and title same as everyday's talk, quality safety, COVID-19, and definition of title is civil field engineering, quality AnnexSL, COVID-19, safety, health and environment, engineers role, designs, construction methods, contracts, organizations, communication, coordination, and why be behind quality. Question that every day I talk of because of competency certificates, because of other certificates, because of certain higher profile certificates which people have and which relate to their smart behavior, which relate to their discipline. But does it do? These certificates give something. These are only indicative certificates. These are not, you can say, end certificates. And millions of professionals around the world have such certification in addition to various other certificates. But what is meaning of these certificates? Should we not consider as human being, as citizen, or as professional? What we think of these certificates, that these are only papers or instruments of interest or instruments of status, or what are these? What these are? Should we not think about that? I think as a good citizen, as a concerned citizen, it's my duty to think about that. Think about what? Think about what do we do with these certificates? We are important, or these certificates are important, or work is important? What's important? If you compare these three, my mind says that it is work which is important. It is work that gives us more certificates. It was work in education that we earned certain academic certificates. It was our work in profession that we got more certificates, competency certificates, and you can say professional certification in every field of life. Maybe engineering, maybe medical, maybe non-medical, non-engineering world. Then what does it mean? If work gives a certificate, what about work? Question arises. I don't want to keep these certificates displayed on walls. Now that's not my purpose. That's not my function. That's not my, you can say, my requirement. My purpose is that I should serve people with power of these certificates, and that service is not normal. That service is based on this point. That's called quality. If I myself, or my you can say colleagues, my community people are not able to work quality system, to work for quality system, to work for quality, then there should be no problem, no issue. But does it happen that way? That's a point to be noted. That's a point to be seen. Quality is not just a, you can say, consideration. It's not just consideration or assurance. People usually say assurance. No, I would not say assurance, because this term is not logical. It is not assurance, it should be reality. It should be reality. It must be a reality. Because when we spend money on materials, on resources, on equipment, on technology, money of people, each individual is spent on whatever product one buys, whatever good one buys. A buyer should get what buyer expects or what buyer is told, is informed. If buyer is informed, something or some inputs or some profile of that product, you will get this profile, I mean to say performance profile, and buyer trusts and buys it. Buyer wants to realize that, and in case buyer doesn't realize that even 10% or 20%, buyer becomes upset because buyer expects something and that's not delivered to buyer. Seller just claims that you will get this, but that claim is not fulfilled. This means buyer is not given justice. Buyer is not given justice by that seller, and that is a point here we have to concentrate. Product may come from whatever source, whatever organization, whatever company, whatever industry, big or small, branded or non-branded, footpath people or non-footpath people, biggest industrialist. I don't care for that. If product has quality, it may come even from a footpath, it may come even from a local vendor. It satisfies me as far as performance is concerned. But it doesn't satisfy me. Even it may come from USA, biggest top manufacturer, or our country, Bharat, India's top manufacturer of national level or international level. If product doesn't satisfy me, I don't consider that as product but as garbage, as a scrap, as non-existing material or quality less material product. I won't regard that substance, that material for which I pay and I don't get what I paid for. And what I say, that is called quality, which must move along with quantity. I don't want to see two separate. Quantity and quality are same blood, same body, same function. They should work together. If quality works and quantity doesn't work, performance doesn't work, that product is nothing but disregardable, condemnable, thrashable. And that manufacturer is also thrashable, whoever one be. That is what meaning of quality stands for. If I buy something, I don't get that, then certainly as a consumer, as a customer, I have every right to be disappointed, to fight with that supplier or manufacturer, and to not just I lost my money. Question is not that. There's another question, my aspirations, my expectations, my time value, my efforts, and why I gave this money to that person without having any requirement guarantee. They shall give you guarantee also. They shall give you guarantee also, limited guarantee for 1 year, 2 years. They will give 3 years with explanations that this item is not valid and this item is not valid or this item is not covered. In fact, only name is covered in that guarantee, not parts. Such guarantees are nothing but fake statements, I should say. If your product doesn't work in beginning itself, what's meaning of guarantee? What's meaning of warranty? We have to analyze that fact. Buying a product and when you get it, it doesn't work at new stage or it may not work in 1 week. It is same thing. that your product is not worth for 1 week or at delivery time, then what's meaning of guarantee for 1 year or 2 years? That question must be raised by everybody. We are not here living in this world and paying money to these people just to be cheated. No, they cannot say this is machine, this happens. Machine means what? At least it should work within guarantee period, if not for whole life. You are placing guarantee, this is a contract. People don't understand this. If I buy something as as a buyer, I buy, I pay to seller. There is a contract between buyer and seller that I am employer and you are a vendor. Of course I pay money, I am employer, maybe of very small level. Or you are a vendor because you are rich. You are a business person, you are industrialist, but you are my contractor. I am your client. For whatever item, for whatever cost, doesn't matter. You gave me this material, I paid you money. There are some conditions with that. You are saying I am giving this guarantee. That itself becomes a contract, maybe unwritten, but unwritten or not unwritten doesn't matter. Question is, I paid to you, this is your material and you are responsible for that. Warranty doesn't mean escape from responsibility. And warranty doesn't mean also that you give me money back. No. This is a contract. This contract doesn't mean I should accept back my money. You are responsible for this product. If it worked at least for guarantee period, I may be little happy that it worked for guarantee period successfully without causing any problem. You have a business trend. They sell you product with discounted amount maybe, and there's 1 year guarantee is covered. We will take responsibility for 1 year, and post 1 year you have to pay us AMC charges. Then you have to pay AMC charges every year for whatever number of years, maybe 5 years, 6 years, depends. And that AMC charge is also very expensive. It's not small charge. It is maybe, if it is for 5 years, you may say they will charge not less than half rate of that product, or maybe 25-30%. Means in 5 years, coming 5 years, they will get you double that amount which you bought for. That is very, very questionable conduct. Initially, to sell that product, they will not charge much amount, but with interest they will charge during maintenance period and post-maintenance period. In maintenance period also they may say this part is not ours. They can cause any complication because conditions apply, they always say. So my question here is, you have a business plan that reduce this cost at time of sales or initial sale, and then indirectly get that money at time of AMC. And don't worry about warranty period because it may cross warranty period. But even if it doesn't cross warranty period, you will send your person, your representative to repair it. This means your product requires repairs within that warranty period also. Where then quality stands? I don't understand this point. What does quality mean? What does quality mean? Every person has to ask, every engineer has to ask. Ultimately, it is, you can say, working responsibility of engineering community, maybe civil, maybe mechanical, electrical, or maybe some other discipline. It is responsibility of engineering community, but unfortunately, engineers may not be involved in this procedure except manufacturing. Even if they are involved in manufacturing, there should be manufacturing process. There should be manufacturing system and quality requirements which must be Means you did not analyze your product itself and you claim only that its life is 5 years, but there are parts which may break even in 6 months or in 2 months or in 1 year. This means you did not include those parts which can work for 5 years. When you say life is expected 5 years, let us say, then for 5 years every part should work. Yes, there can be accidental breakdown, I understand. There can be whatever reason that is justifiable. But it should be frequent, you think? It should not be frequent. If immediately I get new product delivered and it doesn't work, where do you explain that? How do you explain that? That your product could not even work, could not even be commissioned in beginning itself. I could not commission that. Then what's the reason? This means your quality system does not work, or your quality system is having no weight. It is weightless. It is not logical. It is not based on your working system. Certificate is valuable only, as I said. It's only valuable if you work, you use that. Certificate got no meaning if your product says no. Again I say, certificate is no guarantee. It's only a nameplate, nothing else. If you can't give quality, do not claim that you are a certified person. I don't accept person who claims that one is certified but product is quality less. That is very important point I am making. It's not a joke. It's question of transactions of billions and trillions of dollars around world. You may say maybe you're expensive, you're not expensive, doesn't matter. Expense doesn't come into picture. Maybe I am telling this, maybe there are millions of people who have same experience, but some come out loudly and some digest because maybe I have bad time, I got bad product, others don't, but I don't believe it. When there is a lapse in quality, it's not for one product, it's for complete function of that organization, that workshop, or that manufacturing unit, or that manufacturing industry. It's everywhere. There can be defects in composition, there can be defects in size, there can be defects in performance, there can be a defect of whatever sort. Don't be attracted by packing, don't be attracted by color, don't be attracted by, you can say, design, don't be attracted by what they display on internet for sales, don't be displayed by SMS they send after purchase. No, I did not buy for that. I did not buy that I should get many SMS. I am not interested in SMS. I am interested in product quality. That is first requirement as far as product is concerned. And there's another requirement of safety as far as people are concerned, health is concerned, safety is concerned, and you can say environment is concerned. I combine these two. Of course, safety works forever and it also works during manufacturing. During manufacturing is different kind of safety, while another safety lies after product is completed. But quality lies throughout. It lies from beginning of manufacturing to end of use of product. End of use of product is very long period. It may be decades, it may be years. Some product may be used only for few years. It happens sometimes, if you go to HP, for example, you go to their service center and ask them that this computer system is to be repaired, it's not working. They'll simply generally ask how many years it's old. And they won't entertain if it's more than, say, 5 years. This means they know that their product is good only for 5 years. After that, this is a scrap. They don't tell this, but practically it happens. 5 years is considered maximum. Also for cars, for transport systems. Generally, it is 5 years. After that, they say, okay, for 5 years this worked for you, so it's good one. This means this is not lifelong, and that 5 years may be considered life of that project, that product. Therefore, even if we consider 5 years, it should work for 5 years. If in 5 years, 1 year is, say, for example, is included in warranty, that they come and repair, and 4 years they have to pay. This means 4 times they charge half of that for maintenance. For maintenance, this is 2.5 times they charge from you for 4 years, or say 2 times, if not 2.5 times. 2 times plus, you can say 5.5, 2.5 times you have to pay them of initial charges, and total life cost is 2.5x. X means per year. That this means they enter huge profit. They entered in profit in name of maintenance cost, maintenance charges, maintenance system. Customer doesn't realize this, and it only remembers initial cost, and then AMC is a must, because without that you cannot sleep well, that my product may not work. So what I mean to say is, quality is abused. Quality is abused everywhere, and it is completely abused in our beautiful nation, Bharat, India, by every manufacturer, top to bottom. I know it may be highest reputed profile manufacturer. It may be lowest profile. I can't blame lowest profile, because when higher profile, highest profile do not care, you can repairs, as if you are doing an obligation. Customer is nothing. Payment is done by customer, and you are in line yourself because you want repair. This happens, and these people think they are everything. They do not respect customer. That's also a fact. Where there is respect, if you don't care for why your system breaks? My question is that. Okay, occasionally I agree. Maybe just like Sigma says, 3 pieces in 1 million, that may be exceptional. But if it happens, if you go to see any service center, you will find a queue of people there. Go to any service center, whatever service center I have visited, and really I was disappointed. I was disappointed with crowd of people there. Crowd, I mean to say, even if there are 5 to 10 persons sitting and waiting, it can be called a crowd in a small office. If you call them, you call Microtech people, you call some other, you will not get appointing answer, you will not get happy answer, you will not get pleasing answer. You have to wait. I don't want to explain every time what happened with me as far as these products are concerned. Only I can say it's upsetting, it's disappointing, but problem lies in all manufacturers are like that. All products manufacturers are like that. I talked to someone, he says this would happen because these manufacturers do not manufacture themselves. They just buy from vendors, local vendors, like local, as you employ people for manufacture, these vendors also manufacture. They just buy from them and put their seal on, logos on that. Then there is no meaning of brand. Don't think brand is everything. It's just a name. You are paying money for a name and not for product. That's happening. Don't trust these people, whoever they are. They play with us, they play with our money. Now that time has gone when we can say efficiency in government office is bad and efficiency in private offices is good. That time has gone. It has gone long back. It's no difference now. It may be government office. Well, government office never works. but private office charges a lot and delivers very little. You can fight with them, go on fighting, they won't care. They won't respect you. They will try to direct you again and again, do this and do that. And I can kick them, that's my habit. I don't care for such people. After all, it's a question of my money. I gave money and you received money. It's your duty to get me good product, and if you don't give, it's my duty to kick you. Maybe you mind this language, but it's not question of language, it's question of trust. Why should I trust these manufacturers? But all manufacturers are same. In that case, you are helpless, because you have to buy from one of them, and same applies to everybody. You pay for product, you pay for their profit, you pay for their transport, you pay for the product's packing, you pay for delivery. When they say free home delivery, it's just a drama. You have to pay somewhere. And when you are delivered product, you install that product, commission that product, and if it doesn't work, then you have to face a problem. That is a point which is critical. If on your first call they replace it, it's okay, fine, at least they care. But they don't do that. They don't do that. Means you have paid, finished. You did not do any obligation on them. You have to buy, you paid. And now you have to suffer. You have to go to the service center, you have to go somewhere else. They don't just do anything. They will say we'll take 2 months, or we'll take 2 weeks, or we'll take 3 weeks, or 1 day, whatever is procedural. At selling time, they will not take much. They may say we'll deliver in 4 days, but you will find product delivered next day, because they want to get money done. They have to prove at the beginning, see our services. Courier boy would come and deliver a parcel, and that courier boy has no responsibility to make sure that product works or doesn't work. It's your responsibility. You are fortunate enough if that product works, and if it doesn't work, it's your bad time. That's what happens. Enough means it's better to buy from shop. If you can go, at least you can ask him to test it, and that doesn't test, don't buy it. At least test will give you products working. Just like buy a bulb or electric appliance, that shopkeeper tests it and shows to you that's working, and you buy it. And if it doesn't work, it doesn't give you. But here it doesn't happen. It happens many times with me, and maybe probably with thousands of others. It could happen, it may happen. It's very important. Quality has to be quality and not a formality. Quality requires to be a quality and not a statement. That point engineers must realize. I am stressing on engineers because engineers are involved in manufacturing and quality, and in construction they are involved, no other person. Even if they are not listened, they are not cared, they are not heard, but they are responsible. It's not their owner is responsible. Engineers are responsible, because it's engineers, they design product, it's engineer, they manufacture product, and after manufacturing, it goes into hands of those who deal in commercial work, and they decide price, they decide everything, and they administer, they take orders, marketing, etc. they do. Engineers are stopped there at time of delivery. Engineers, I think, can do a lot, because engineering means a lot of thinking, a lot of doing, a lot of producing, a lot of quality. But how much they do it, or they just do formality, that I inspected that. If that too is a formality, then it's very bad situation. I can say very, very bad situation. It's only engineering which defines everything. It's nothing else. Its engineers must realize quality effects, and particular civil engineers and many extended branches of engineering would have to change quality aspect of society, or else quality cannot exist. Very, very important point. quality cannot exist. Systems quality to be devised by engineers and achieved by engineers. If system is broken, means broken life, broken everything. Do we want to say broken system? That point we have to ensure that system should work. It should not be just a game. It should not be just on papers. It should work successfully without fail. It's very important point. Professional individual quality should be amended. Individual attitude should be amended. It should be forced. Members should be forced. Engineer and engineers associates should be forced to amend themselves. And I am sure can do, but maybe there are restrictions on them. It is commercial force, it is business force, it is organizational management force, because those who are in management, they least bother about quality. For them, business is quality, profit is quality, more and more demands are quality. For them, quality is no quality. They consider it, but they don't understand without quality your product cannot be successful. Professionals' individual quality must be amended, modified, and one must be forced to amend its quality for reliability by additional teaching or by additional learning or by additional knowledge dissemination. I'm not talking of structures in this, but reliability factor is very important. I only can say all stages in designs being very significant, but merely design does not work, does not suffice. If construction, development, or manufacturing are not affected to specified marks required or defined, quality cannot be allowed to be ignored. Design drawings must have quality input, quality criteria, and duly coordinated to produce working details, keeping every site working conditions. For site cannot be relied upon automatically, but provide clear notes, specify properly and explicitly. Manufacturing or construction based on reasonable, coordinated, constructible or manufacturable quality designs and safety, health and environment requirements fulfilled. All activities must be taken care of, but it doesn't happen. Reasons being lethargy in attitude and undue strains in minds. Why should site work suffer? Why should manufacturing work suffer? Why should industrial work suffer? Because of deficiencies in designs or deficiencies in working procedures, in working process. Design accountability must be fixed. If accountability or constructed product or element is required, design and construction or manufacturing qualities are complementary. I don't say that factories don't work properly. They work properly, but they do not care, they do not concentrate. They because start thinking of production only. And they never do proper maintenance, and even if they do that, then product should be good product. It doesn't happen. Or there may be some other problem, some other gap in controls which must be required, which must be open to everybody. Well, in factories, you can say in industrial units, everything is defined, method is defined, procedure is defined. But definition is not enough. Just definition on papers is not enough. It should be on work. It should be in hand. It should be in shop. It should be on flow. It should be in manufacturing unit. That should be there. But there is something somewhere, incorrect or wrong, that quality falls. And what is that? That must be discovered. That must be traced out. Because if you miss quality, product is missed. If you can't commission or even successfully commission and breaks down, it's very disappointing. It's very, very disappointing. Yes, if it breaks down after say 1 year, 2 years, that is acceptable sometime because there can be many reasons for that. But if it doesn't work at all and you are delivered of a product you expect that it will work, perform well, and you find that it's not performing well when you start it, what level of dissatisfaction do you have that time? You can imagine. If it happens with me, how shall I think of? Means I be surprised why this product's not working. Really, it's a big surprising issue. Newly delivered product, it doesn't work. It's not second hand, it's new product. And I pay price for that. It's delivered. I find it's not working. What mind state would be at that time? It's not normal, it's abnormal. Means you are now captured by those people. You have paid money, you are delivered, and you can't do anything. Keep on writing. They don't bother because they have millions of customers probably, and they think I'm lying. Customers lying. There's no research on that. There's no survey on that. Nobody comes and asks how the product's working. You install it, you buy it, nobody will ask you whether or not it's working satisfactorily. They will only ask, tell us about our service, how we serve you, at this stage, at this stage, at this stage, at this stage. Give feedback, how many marks you use. They will be concerned only for them, not for a product. Not for a product. They will never ask you, please tell me, sir, tell me, customer, how my product is working. Is it good or not? Is it what you bought for or not? No one questions. Then where is quality? I ask everybody, what do you mean by quality? Is finishing good, color good, or working good? Really, you can say very, very important points these are. You have to understand these points. Now, I'll not go too much in depth of this because every time I talk about this and there's no meaning, only I would say at the end, which is there, missing, which is what's missing. This is missing. It simply says quality non-performance, quality non-compliance on product is called substandard and therefore must be rejected. Non-conformance means engineer is either careless or ignorant or incompetent one, and therefore is a redundant personnel. We must change to meet requirements to achieve intended quality standards for universal recognition of products or goods. Quality requirements checks being a must. Quality requirements checks being a must. Missing which we have to blame ourselves for quality future failure. Quality failure. Engineering means quality application and continuous improvement of quality. No way exists not to comply with defined or specified quality levels because definition of quality is a must, and that definition requires to be achieved or else work leads to status of being unsuccessful and to be performed. This is only message for everyone. It's very important we have to be in that regard. Now I go to my safety issue, safety, which we already continued discussion on this. Last time too we did. Hazards control. Hazards everywhere we have to control. How to control hazards? That point is very important. And that briefly I had given in only for consideration these items, these points, but we were discussing about concrete and other items. Let's go and see these temporary works, etc. We discuss about excavation, we discuss about control measures and excavation. We were discussing about cylinders. Gas cutting, we were discussing with gas cutting. So let us say again we'll talk gas cutting activity. That's also very important one. It should be discussed properly. And gas cutting, though it's mechanical engineer's job, no problem. It's common sense job also. So we can concentrate on this gas cutting. And what are hazards in that? Possible hazards. Cylinder can explode, ice can be damaged, fire can break, and explosion risk in live plants. These can be considered hazards. In rare cases though it happens. And what are control measures? That's also a point now. Oxygen cylinders, we have oxygen cylinders, we have valve fittings, we have to be kept free from grease, oil, that we discussed. Flashback arresters must be fitted to these cylinders because flashback means accident, flash should not go back. Gas hoses, I am saying flash should not go back when flash is working, cylinder is working. That should be outside cylinder and not inside, because if it's inside, what shall happen? It shall certainly explode. Gas hoses, gas hoses, pipes, gas hoses and gauges, because hose and gauge are linked together. Gas hoses and gauges to be maintained in safe condition and inspected daily. Defective hoses and gauges are to be replaced immediately. Don't wait for. If you wait for, you may be in problem. Cylinders to be used in vertical position and secured against falling. It should not fall. Remember, people don't understand this, and I think they are not instructed as well. Maybe they are instructed, but they don't care. So you can say cylinders to be used in vertical position and secured against falling to avoid leak and explosion. Personnel carrying out gas cutting operations shall wear suitable eye protection. It's a must. When we work on gas cutting operation, eye protection wearing is a must. Suitable measures, that is provision of fire blanket or measure, namely provisions of fire blanket, fire. And I explained last time fire watch. I think you remember that. What we make a fire watch is a very important point. Fire watch, fire lookout. Yes, I showed to you this. Fire lookout, I'll refer again what we discussed in that, because that's very important point. Fire watch, tower, etc., whatever it could be, it's very important. And we had discussed with this. I'll just show it to you what we discussed, nothing else. Fire lookout, etc., we discussed that fire watch is a person assigned duty to look for fire from top of a building, known as fire lookout tower, These towers are used in remote areas, normally on mountain tops with high elevation and a good view of surrounding terrain to spot smoke caused by wildfire. We can say also it was that part of lookouts duty include taking weather readings and reporting findings to emergency communication center, which is there already, and often several lookouts shall overlap. And this is also there that once a possible fire is spotted, smoke reports or lookout shots are relayed to local emergency communication center, often by radio or phone. A fire lookout can use a device known as Osborne Firefinder. And is liable to survive without any other human interaction. So you can say, for example, there are as name of some countries that use fire lookouts: United States, it is then Canada, in which BC, Alberta, Saskatchewan, Manitoba, Ontario, Nova Scotia, Mexico, Uruguay. These just names can see if you can. Hallie Morse, for example, first female fire lookout for US, then that this are there. Now, additional information. Suitable measures, namely prevention or provision of fire blankets, fire watchers, shall be used to prevent risk of fire during cutting operations. Prior to gas cutting operations in live plant areas, gas checking shall be carried out and work should and hearing protection, because hearing can also be, the ear can also be damaged. Changing of abrasive wheels to be carried out by trained and authorized personnel only, using proper disc spanners. Disc spanners. Personnel carrying out grinding work shall wear suitable eyes and hearing protection, and grinding operations in live plant areas shall be carried out in accordance with permit to work requirements. Grinding operations shall be controlled in order to prevent risk of injury to other personnel from sparks, metal splinters. Immediate medical aid should be made available in case of injury to controls. Some problem I think in this. So it is grinding abrasive cutting. Grinding is a type of abrasive machining. It's a type of abrasive machining process which uses grinding wheel as cutting tool. A wide variety of machines are used for grinding. Hand cranked hand cranked knife, sharpening stones, thus grindstones, then handled power tools such as angle grinders and die grinders. Various kinds of expensive industrial machine tools called grinding machines, bench grinders. Here you can say this is machinist grinding workpieces on a bench grinder, fixed on a bench. So in machining fields, term cutting is often understood to refer to macroscopic cutting operations, and grinding is often mentally categorized as a separate process. This is why terms are usually used separately in shop floor practice. Lapping and sanding are subsets of grinding. Grade, resin, bond are used to keep workpiece temperature low. The advantage of wheel that is constantly degrading requires high spindle power, 51 HP or 38 kilowatt, and is limited in length of part it can machine. To address problem of wheel sharpness, continuous scrape feed grinding CDFCF, continuous dress keep feed grinding was developed in 1970s. Wheel is distressed constantly during machining. In CDFC, continuous dress keep feed grinding process and keeps wheel in state of specified sharpness. It takes only 17 seconds to remove 16 centimeter cube of material, a huge gain in productivity. 38 HP, 28 kilowatt spindle power is required with a low to conventional spindle speed. Limit on part length was erased. High efficiency deep grinding. High efficiency deep grinding is another type of grinding. This process uses plated super abrasive wheel. Plated super abrasive wheels. These wheels never need dressing and last longer than other wheels. This reduces capital equipment investment costs. High efficiency deep grinding can be used on long part lengths and removes material at a rate of 16 centimeter cube in 83 seconds. HEDG requires high spindle power and high spindle speeds. So in one case it was, we say, in first case of creep grinding, time was, you can say, it was 1 second, 117 for 16 centimeter cube, and in precision grinding it was 200 seconds to do same. Say for CFC has disadvantage of wheel that is constantly degrading and high spindle power is required. Same way you can say other description is for continuous dust creep grinding, and this wheel is constantly during machining, and 17 seconds remove that 16 meter cube. Likewise we can say that high efficiency deep grinding. High efficiency deep grinding HEDG is another type of grinding. This process uses plated suppressive wheels. This process uses plated suppressive wheels. These wheels never need dressing and last longer than other wheels. This reduces capital equipment investment cost. HEDG can be used on long part lengths and removes material at a rate 16 centimeter cube in 83 seconds. HEDG high efficiency deep grinding requires high spindle power and high spindle speeds. Peel grinding patented under the name of quick point in 1985 by Irwin Junker. Machinic Fabric GmbH in Norddeutsche Germany uses a thin super abrasive grinding disc oriented almost parallel to a cylindrical workpiece, operates somewhat like a lathe turning tool. Ultra high speed grinding can run at speeds higher than 40,000 fpm or 200 meters per second, taking 41 seconds to remove 16 meter cube material, but still in R&D stage. It also requires high spindle power. Cylindrical grinding, so we have gone through how many grindings? Creep feed grinding CFG, then continuous dress, then high efficiency deep grinding HEDG, you can say peel grinding, and then ultra high speed grinding. Now cylindrical grinding. Cylindrical grinding also called center type grinding, is used to grind cylindrical surfaces. Cylindrical grinding, also called center type grinding, is used to grind cylindrical surfaces and shoulders of workpiece. Workpiece is mounted on centers and rotated by a device known as lathe dog or center driver. Abrasive wheel and workpiece are rotated by separate motors and at different speeds. Table can be adjusted to produce tapers. Wheel head can be swiveled. 5 types of cylindrical grindings are outside diameter grinding OD, inside diameter ID grinding, plunge grinding, creep feed grinding, and centerless grinding. A cylindrical grinder has a grinding abrasive wheel, 2 centers that hold workpiece, and a chunk. Grinding dog or other mechanism to drive work. Most cylindrical grinding machines include a swivel to allow forming of tapered pieces. Wheels and workpiece move parallel to one another in both radial and longitudinal directions. Abrasive wheel can have many shapes. Standard disc shape wheel can be used to create a tapered or straight workpiece geometry, while formed wheels are used to create a shaped workpiece. Process used a formed wheel creates less vibration than using a regular disc shape. I think I should be back in a couple of minutes. Meanwhile, you can go through this. It's better because daily practice as is. I have to go. Give me 10 minutes, please. The resistance, I keep it open and go for that. So we can go further and see what's happening here. That's point here. We have to understand what's happening. We have to see how it's working. We have to see. And I was talking about issue of this information, that is cylindrical grinding. Cylindrical grinding, it's a very important one. So we're talking of this. We're talking of cylindrical grinding. Has a grinding wheel, two centers. Grinding wheel with two centers. It has that hold workpiece and a chunk grinding dog or other mechanism. To drive work, most cylindrical grinding machines include a swivel to allow forming of tapered pieces. Wheel and workpiece move parallel to one another in both radial and longitudinal directions. Abrasive wheel can have many shapes. Standard disc shape wheel can be used to create a tapered or straight workpiece geometry, while formed wheels are used to create a shaped workpiece. Process using a formed wheel creates less vibration than using a regular disc-shaped wheel. Tolerances for cylindrical grinders are held within plus minus 0.005 inches or 13 micrometer for diameter, and plus minus, or you can say 2.5 micrometer for roundness. Precision work can reach tolerances as high as 1.3 micrometer for diameter and 2.25 micrometer for roundness. Surface finishes can range from 51 nm to 3.4 micrometer. Nm was nanometer, with typical finishes ranging from 0.2 to 0.81 micrometer. Surface grinding. Surface grinding uses a rotating abrasive wheel to remove material, creating a flat surface. Tolerance that are normally achieved with grinding are 5.1 micrometer for grinding a flat material and 7.6 micrometer for parallel surface. Surface grinder is composed of an abrasive wheel, a work holding device known as chunk, either electromagnetic or vacuum, and a reciprocating table. Grinding is commonly used on cast iron and various types of steel. These materials lend themselves to grinding because they can be held by magnetic chuck, commonly used on grinding machines, and do not melt into wheel, clogging it and preventing it from cutting. Materials that are less commonly grounded are aluminum, stainless steel, brass, and plastics. These are less commonly ground. These all tend to clog cutting wheel more than steel and cast iron, but with special techniques it's possible to grind them. Others. Centerless grinding. Centerless grinding, you can see that center stationary wheel, moving wheel, workpiece, and work rest. Centerless grinding is done when workpiece is supported by a blade. Workpiece is supported by a blade instead of by centers or chunks. Two wheels are used. Larger one is used to grind surface of workpiece, and smaller wheel is used to regulate axial movement of workpiece. Types of centerless grinding include through feed grinding, in feed, plunge grinding, and internal centerless grinding. Centerless grinding, you can say, that is this one. electrochemical grinding. Electrochemical grinding, let's say, it's type of grinding in which a positively charged workpiece in a conductive fluid, positive charged workpiece in a conductive fluid is eroded by a negatively charged grinding wheel. Pieces from workpiece are dissolved into conductive fluid, and that is this ELID. That is what says electrolytic in process dressing. ELID, electrolytic in process dressing, is one of most accurate grinding methods. In this ultra precision grinding technology, grinding wheel is dressed electrochemically and in process to maintain accuracy of grinding. An ELID, that is electric in process dressing, cell consists of a metal bonded grinding wheel. Metal bonded grinding wheel, a cathode electrode, metal bonded grinding wheel, a cathode electrode, a pulsed DC power supply, and electrolyte. Wheel is connected to positive terminal of DC power supply through a carbon brush, whereas electrode is connected to negative pole of power supply. Usually alkaline liquids are used as both electrolytes and coolant for grinding. Alkaline liquids are used as both electrolytes and coolant for grinding. A nozzle is used to inject electrolyte into gap between wheel and electrode. Gap is usually maintained to be approximately 0.1 mm to 0.3 mm. During grinding operation, one side of wheel takes part in grinding operation, whereas other side of wheel is being dressed by electrochemical reaction. Says during grinding operation, one side of wheel takes part in grinding operation, whereas other side of wheel is being dressed by electrochemical reaction. Dissolution of metallic bond material is caused by dressing, which in turn results continuous protrusion of new shape grit. And here you can say, let's just blow it up. It gives us this diagram. I mean, it's not very clear, but it's given here clearly. Means electric circuit going like this, and well, doesn't matter. Like let's go down here. Now form grinding. It's specialized type of cylinder grinding where grinding wheel has exact shape of final product. Grinding wheel doesn't traverse workpiece. We can say here internal grinding is used to grind internal diameter of workpiece. Tapered holes can be ground with use of internal grinders that can swivel on horizontal. Pre-grinding, a new tool has been built. When a new tool has been built and has been heat treated, it's pre-ground before welding or hard facing commences. This usually involves grinding OD slightly higher than finish grind OD to ensure correct finish size. Grinding wheel. A grinding wheel is an expendable wheel used for various grinding and abrasive machining operations. It's generally made from a matrix of coarse abrasive particles. Pressed and bonded together to form a solid circular shape. Various profiles and cross sections are available depending on intended uses for wheel. Grinding wheels may also be made from a solid steel or aluminum disc with particles bonded to surface. Lubrication. Use of fluids in a grinding process is often necessary to cool and lubricate wheel and workpiece, as well as remove chips produced in grinding process. Most common grinding fluids are water-soluble chemical fluids, water-soluble chemical fluids, water-soluble oils, synthetic oils, and petroleum-based oils. It's imperative that fluid be applied directly to cutting area to prevent fluid being blown away from piece due to rapid rotation of wheel. Here are some examples. Grinding, abrasive cutting, work, we now say work material, aluminum, brass, cast iron, mild steel, stainless steel, plastics. It says aluminum, and the cutting fluid is light duty oil or wax, application is flood. Brass, light duty oil, application is flood. Cast iron, heavy duty emulsifiable oil, light duty chemical oil, synthetic oil, flood. Mild steel, heavy duty water soluble oil, flood. Stainless steel, heavy duty emulsifiable oil, heavy duty chemical oil, synthetic oil, that is flood. Plastics, water soluble oil, heavy duty emulsifiable oil, dry, light duty chemical oil, synthetic oil. These are cutting fluids examples. It says here, take note of other machines. One on right side, right hand, dipping workpiece in a lubricating solution. So is that. Now workpiece, work holding methods. Workpiece is manually clamped to lathe dock. Powered by faceplate that grinding wheel rotate in opposite directions, and small bits of piece are removed as it passes along the grinding wheel. In some instances, special drive centers may be used to allow edges to be ground. Work holding method affects production time as it changes setup time. Workpiece materials. Typical workpiece materials include aluminum, brass, plastics, cast iron, mild steel, and stainless steel. Aluminum, brass, and plastics can have poor to fair machinability characteristics for cylindrical grinding. Cast iron and mild steel have good characteristics for cylindrical grinding. Stainless steel is very difficult to grind due to its toughness and ability to work harden, but can be worked with right grade of grinding wheels. Workpiece geometry. Final shape of workpiece is mirror image of grinding wheel, with cylindrical wheels creating cylindrical pieces and formed wheels creating formed pieces. Typical size of workpieces range from 18 mm to 1 meter and 2 cm to 4 meter in length, although pieces from 6 mm to 1.5 meter in diameter and 0.3 or 8 mm to 2.5 meter in length can be ground. Resulting shapes can be straight cylinders, straight edges, conical shapes, or even crankshafts for engines that experience relatively low torque. So it says typical size on workpieces range from 18 mm to 1 meter, 2 cm to 4 meter in length, and pieces of 6 mm to 1.5 meter in diameter and 0.3 and 8 mm to 2.5 meter in length can be ground. Resulting shapes can be straight cylinders, straight-edged conical shapes, or even crankshafts for engines that experience relatively low torque. Effects on workpiece material. Chemical property changes include an increased susceptibility to corrosion because of high surface stress. Mechanical properties will change. Mechanical properties shall change due to stresses put on part during finishing. High grinding temperatures may cause a thin martensitic layer. High grinding temperature may cause a thin martensitic layer to form part, which shall lead to reduced material strength from micro cracks. Physical property changes includes possible loss of magnetic properties on ferromagnetic materials. And we have there cryogenic grinding, diamond grinding of pavements, flat honing, grinding dressers, height stock removal, honing, metal working, hydroerosive grinding shaft. And then there are references which are of no meaning. Let us say now go back here. This was that we like to, we try to, I like just to save it and okay, grinding abrasives is just already there. Now I close this file just after a review of this. We have gone through this here, and I like to go back to for more information about this. Let's go back to for information about this, and that could be, let's say, if I can get something back to Firewatch. I think yesterday I could not get everything, so let's see if we can get something. So let's see what's that. Okay, let me see. Not much in this. Firewatch is in person assigned to keep watch on hot work and fire hazards. Let us see if it can be possible. Let's some information on this we give you. What it says Firewatch here. It is what is Firewatch? Was man. Firewatch is when a person. Firewatch is when a person is assigned to keep watch on hot work and fire hazards in an area that doesn't have automatic fire warning systems or fire suppression systems. It says Firewatch is when a person is assigned to keep watch on hot work and fire hazards in an area that does not have automatic fire warning systems or fire suppression systems. A fire watch is required if some of fire systems is not working temporarily, or if none is placed yet. It's usually only a short-term solution before fire systems can be repaired or installed. A responsible person who must have fire suppression equipment with them performs a fire watch. Area to be watched for fire is patrolled by fire watch personnel and action taken in event of fire. There is not much in this. I should not waste time on this. There's some safety signs here, so I think it's no use, leave it. So we go back here, find something else. What's this? Firewatch Wikipedia. What is Firewatch? So what is this? Firewatch alarm. What it says? It's also exactly important. Here some pages can the form is the search for products, a fire alarm, trusted source for Firewatch. National law and codes dictate that a firewatch is to be put in place if a building's fire alarm system, fire sprinkler system, or a fire suppression system is out of order for a period exceeding 4 hours, whether this is a pre-planned outrage or it's not. It's important Firewatch is instated in order to ensure your building, campus or facility is properly protected from fire. Firealarms.com. Okay, highly trained and certified for. Okay, I know our personally does. I'm interested in definition only. It says national law and codes dictate that Firewatch is to be put in place if a building's fire alarm system, fire sprinkler system, or fire suppression system is out of order for a period exceeding 4 hours, whether this is a pre-planned outage or not. It's important Firewatch is instated in order to ensure your building, campus or facility is properly protected from fire. Then notifying fire department, our Firewatch, notifying fire department, what it says, if watch is there, notifying fire department and building occupants of emergency, keeping diligent watch for fires, preventing a fire from occurring, and extinguishing small fires, using a portable fire extinguisher or hose, protecting public from fire or life safety dangers, warning occupants of whatever hazardous conditions requiring evacuation. One-time normal fire watch can cost an exorbitant amount of money. With fire alarm, we want to keep you protected, but we want to help you repair our system in order to get your system back up and running as fast as possible. Firewatch should be a temporary solution, and firealarm.com aims to make this possible. Use firealarm.com. Okay, leave it now if I am not interested in that. So that's what it says. More services, more on that. So this only AnnexSL now. So I'm not interested in that. So just definition of that we have taken in, and I can save this for future references. May be required, may not be required. So leave it. And now I close it, and we go to something else if you have possibility. Some definition is fine. This happens where I was actually. I was here, Firewatch search, find sexy watch. No, it's not that. So let's be here. What we're discussing about. It is again. So we discussed about grinders and we discussed about that. So we go further here. In this we were discussing grinding, and we says grinding operations in live plants area shall be carried out in the conditions of permit to work, and grinding operations shall be controlled in order to prevent risk of injury to other personnel from sparks, metal splinters. Immediate medical aid should be made available in case of injury to hand or fingers. Housekeeping in areas at grinding operation to be maintained at high level. No cable should lie on floors in working areas to avoid tripping hazards. Grinder operator should concentrate on its working without disturbance. This is very important part. Grinder operator should concentrate on its working without disturbance by either use of mobile phone or talking to others. Precautions should be taken respectively for vertical use grinder as well as horizontal use grinder accordingly. Horizontal use grinders do not require any guide or on vertical use grinders require guide on it. Both types are required to carry out different activities. For example, vertical type is generally used for cutting, while horizontal type is used particularly for grinding uneven surfaces on floors, walls or ceilings. Accordingly, safety issues should be cared about. Now we come to welding. Welding, an activity that also carries hazards with it. Which hazards it can have? Damage to body parts. Damage to body parts. It can result in fire, in explosion, electrocution, health impairment. This is all welders. Welding is very important part, and it says control measures are welders should be provided with and wear following personal protective equipment: welding gloves, overalls, welding goggles, not googles. Actually, there's a problem with Google and goggle. Welding goggles with correct filter. RPE were identified, that's respiratory protective equipment. Flammable materials shall be removed from areas where welding is to be conducted. Remove flammable materials from that area. Fire extinguishers should be immediately made available in areas of welding operation. If it's not practicable to remove these materials, other suitable precautions shall be taken to alleviate fire and explosion risk, namely provision of fire blankets, fire watchers. Fire watcher should constantly surveillance welding activity and act instantly to extinguish fire using fire extinguishers. In case of fire spread, further action should promptly be resorted to. Before welding operations are carried out, materials involved and their byproducts shall be identified, risks assessed, and necessary controls measures identified in order to prevent possible respiratory disease, systematic poisoning, namely cadmium, stainless steel, galvanized lead coated material, galvanized or lead coated materials. Welding cables and cable joints shall be maintained in good condition. Welding returns should be firmly connected to metal on which welding is applied. This requirement to be carried out by firmly connected to metal on which welding is applied. Welding returns should be firmly connected to metal on which welding is applied. This requirement to be carried out by means of well constructed earth clamps only. In order to prevent risk of arc eye injury to other personnel, suitable screens to be placed around welder's working area. Damp, humid and wet conditions shall decide for voltage and type of transformer used. We should understand this. It's very, very important point here. And meanwhile, just a minute please. Let me go back. What to do? I have to open some door. So we'll continue. We are discussing about welders, what welders should do. So we saw what PP they should have: welding gloves, overalls, welding goggles, correct filters, RPs, respiratory protective equipments, and we have to keep flammable materials off from local area of welding. And then fire extinguisher must use. If it's not practicable, then we have to do something else. We have to provide, you can say, we have to alleviate fire and risk from there. Fire blankets, we have to provide. Fire watches, we have to provide. Fire watches should constantly surveillance welding area activity and act instantly to extinguish fire using fire extinguisher. Means in case you cannot do something else, you cannot do. I have to keep in mind, fire watcher must be there with fire extinguisher, that must be used. And in case of fire spread, further action should be promptly resorted to. And then we have to see, before operation starts, whatever material involved in the byproduct shall be identified, assess risks and necessary control measures that we have to do. We have to make sure what happens there. Then we have to, this is a respiratory disease, we have to take care of this, risk assess the necessary control measures identified in order to prevent possible respiratory diseases, symptoms, poisoning, that's cadmium, stainless steel, galvanized coat materials, and welding cables and coil joints shall be maintained in good condition. Welding returns should be firmly connected to metal on which welding is applied. This requirement to be carried out by means of well-constructed earth clamps only. In order to prevent risk of eye injury to other personnel, suitable skins to be placed. Now we go to another one, that is diesel engines, process areas. What is diesel engine process area means? That's activity. Engine exhaust fire and over speeding of engine in live plant, these are hazards. Means engine exhaust fires and over speeding of engines. Control measures: spark arresters to be fitted to diesel engine exhaust. Spark arresters. Shelving valves shall also be fitted where needed. You can say diesel engines, we talked of diesel generators. Now diesel engines, we are talking of what does it mean. We have to be very careful about this. Diesel engines, we have to see what it says about them. Diesel engines, what do you mean by that? Diesel engines, and this is in Hindi. What's coming in Hindi? What's coming in Hindi? I don't know. Wikipedia, let me take this. Diesel engine, I'm talking to something, you know. It's not coming. What's the reason? I don't know. Reason. About cutting. It's cutting now. It's okay. It's cutting now. So it's okay. So we got it. Okay. So it's good one, I think. Diesel engine. Let's browse first what's happened, what's there in this. Can we do something or not? All, I think I'm we are talking of safety viewpoint, we'll see what to do with that. It is, let's say, diesel engine, Wikipedia. Now it's from Wikipedia, diesel engine I'm talking. Diesel engine named after Rudolf Diesel. Name is Diesel, Rudolf Diesel. It's an internal combustion engine, ICE. I studied engines in thermodynamics, so it's an internal combustion engine in which ignition of fuel is caused by elevated temperature of air in cylinder due to mechanical compression. Thus, diesel engine is so-called compression ignition engine, CI engine. This contrasts with engine using spark plug ignition of air-fuel mixture such as petrol engine, gasoline engine or gas engine, using a gaseous fuel like natural gas or liquefied petroleum gas. Diesel, I again repeat this, diesel engine, diesel is named by Rudolf Diesel. Diesel engine is an internal combustion engine in which ignition of fuel is caused by elevated temperature of air in cylinder due to mechanical compression applied. Thus, diesel engine is so-called compression ignition engine, CI engine. This contrasts with engine using spark plug or spark plug ignition of air fuel mixture such as petrol engine, gasoline engine or a gas engine using a gaseous fuel like natural gas or liquefied petroleum gas. Diesel engines work by compression only. Diesel engines work by compression, compressing only air. This increases air temperature inside cylinder to such a high degree that atomized diesel fuel injected into combustion chamber ignites spontaneously, with fuel being injected into air just before combustion. Dispersion of fuel is uneven. This is called a heterogeneous air-fuel mixture. Heterogeneous air-fuel mixture. Torque a diesel engine produces is controlled by manipulating air-fuel ratio lambda. Instead of throttling intake air, diesel engine relies on altering amount of fuel that is injected, and air-fuel ratio is usually high. Diesel engine has highest thermal efficiency, engine efficiency of whatever practical internal or external combustion engine due to its very high expansion ratio and inherent lean burn, which enables heat dissipation by excess air. A small efficiency loss is also avoided compared with non-direct injection gasoline engines, since unburned fuel is not present during valve overlap and therefore no fuel goes directly from intake injection to exhaust. Low-speed diesel engines, as used in ships and other applications where overall engine weight is relatively unimportant, can reach effective efficiencies up to 55%. Diesel engines may be designed as either 2-stroke or 4-stroke cycles. They were originally used as more efficient replacement for stationary steam engines. Since 1910, they have been used in submarines and ships. Use in locomotives, trucks, heavy equipment, agriculture equipment and electricity generation plants followed later. In 1930s, they slowly began to be used in a few automobiles. Since 1970s, use of diesel engine is larger on road and off-road vehicles in US has increased according to Ralph UU average for diesel cars accounts for half of newly registered cars. World's largest diesel engine put in service are 14 cylinders at that time. Two-stroke Marion diesel engines produce a peak power of almost 100 megawatt each. Now, I'm not going to tell all this. Diesel's idea, history figure behind that. In 1847, Rudolf Diesel, who was a student of Polytechnicum in Munich, attended lectures of Carl Linde. Linde explained that steam engines are capable of converting just 6 to 10% of heat, energy into work, but that Carnot cycle allows conversion of much more of heat energy into work by means of isothermal change in condition. According to Diesel, this ignited idea of creating a highly efficient engine that could work on Carnot cycle. Diesel was also exposed to a fire piston, a traditional fire starter using rapid adiabatic compression principles, which Linde had acquired from Southeast Asia. After several years of working on these ideas, Diesel published them in 1893 in essay Theory and Construction of Rational Heat Modes. Diesel was heavily criticized for his essay, but only a few found mistake that he made. His rational heat motor was supposed to utilize a constant temperature cycle with isothermal compression that would require a much higher level of compression than that needed for compression ignition. Diesel's idea was to compress air so tightly that temperature of air would exceed that of combustion. However, such an engine could never perform in usual work. In his 1892 US patent, Diesel describes compression required for his cycle. Pure atmospheric air is compressed. Pure atmospheric air is compressed according to curve 1-2 to such a degree that before ignition or combustion takes effect, highest pressure of diaphragm and highest temperature are obtained, that is to say, temperature at which subsequent combustion has to effect, not burning or ignition point. To make this more clear, let it be assumed that subsequent combustion shall take effect at temperature of 700 degrees Celsius. This subsequent combustion shall take effect at temperature of 700 degrees. Then with that case, initial pressure must be 64 atmospheres, or for 800 centigrade pressure must be 90 atmospheres, and so on. Into air thus compressed is then gradually introduced from exterior finally divided fuel, which ignites on introduction. Since air is at temperature far above igniting point of fuel, characteristic features of cycle according to my present invention are therefore increase of pressure and temperature up to maximum, not by combustion but prior to combustion by mechanical compression of air, and there upon subsequent performance of work without increase of pressure and temperature by gradual combustion during a prescribed part of stroke determined by Carnot. By June 1893, Diesel had realized his original cycle would not work and he adopted constant pressure cycle. Diesel described cycle in his 1895 patent application. Notice that there is no longer a mention of compression temperatures exceeding temperature of combustion. Now it's simply stated that compression must be sufficient to trigger ignition. In an internal combustion engine, combination of a cylinder and piston constructed and arranged to compress air to a degree producing a temperature above ignition point of fuel. Says in an internal combustion engine, combustion of a cylinder and piston constructed and arranged to compress air to a degree producing a temperature above igniting point of fuel. Supply for compressed air or gas. Supply of compressed air or gas. A fuel supply. A distributing valve. You can say. A fuel supply, you can say, a fuel compressor, igniting point says, I missed that. A supply for compressor or gas, a fuel supply, a distributing valve for fuel, a passage from air supply to cylinder in communication with air supply and with fuel valve, and a cut oil substantially as described. Says again, I read. In an internal combustion engine, combination of a cylinder and piston constructed and arranged to compress air to a degree producing a temperature above igniting point of fuel, a supply for compressed air or gas, a fuel supply, a distributing valve for fuel, a passage from air supply to cylinder in communication with fuel distributing valve, an inlet to cylinder or in communication with air supply with fuel valve, and a cut oil. So it's all described, substantially described in US patent files. In 1892, diesel received patents in Germany, Switzerland, United Kingdom and United States for method of an apparatus for converting heat into work. In 1894 and 95, he filed patents and addenda in various countries for his engine. First patents were issued in Spain, France and Belgium in December, and in Germany in 1895, and in the United States in 1898. Diesel was attacked and criticized over a time period of several years. Critics had claimed that Diesel never invented a new motor and that invention of diesel engine is a fraud. Otto Kohler and Emil Kapitein were two of most prominent critics of diesel time. Kohler had published an essay in 1887 in which he describes an engine similar to engine Diesel described in his 1893 essay. Kohler figured that such an engine could not perform any work. Emil Kapitein had built a petroleum engine with glow tube ignition in early 1890s. Claimed against his own better judgment that his glow tube ignition engine worked same way Diesel's engine did. His claims were unfounded and he lost a patent lawsuit. Other engines such as Alcroyd engine and Brighton engine also use operating cycle that is different from diesel engine. Friedrich says that diesel engine is Diesel's very own work and that Diesel's myth is falsification of history. First diesel engine. we have to go further and see what it says. Says first diesel engine talking of diesel sought out firms and factories that would build his engine. Diesel sought out firms and factories that would build his engine. With the help of Morris, Scrotter and Max Luthermut, he succeeded in convincing both Krupp and Essen and machine fabric bust. Contracts were signed in April, and in early summer, diesel first prototype engine was built in Augsburg on August 10, 1893. First ignition effected, fuel was used was petrol in winter. Diesel redesigned existing engine, and by 18 January 1894 his mechanics had converted it into second prototype. On February 17, 1894, redesigned engine ran for 88 revolutions, 1 minute. With this news, machine fabric stocks rose by 30%, indicative of tremendous anticipated demands for a more efficient engine. On June 26, 1895, engine achieved an effective efficiency of 16.6% and had a fuel consumption of 5 per. However, despite proving concept, the engine caused problems and diesel could not achieve any substantial progress. Therefore, Krupp considered rescinding contract they had made with diesel. Diesel was forced to improve design of his own engine and rushed to construct a third prototype engine. Between 8 November and 20 December 1895, second prototype had successfully converted over 111 hours on test bench. In 1890's report, this was considered a success. In February 1896, diesel considered supercharging third prototype. Emanuel Lauster, who was ordered to draw third prototype, motor 250-400, had finished drawings by 30 April 1896. During summer, the engine was built. It was completed 6 of 1896. Tests were conducted until early 1897. First public tests began on 1st February 1897. Morris Strotter's test on 17 February was main test of diesel's engine. Engine was rated 13.1 kilowatt with specific fuel consumption like this. And that's all. Now we go back to go fuck. These are important for us. Let's see. Operating principle, characteristics. Now, what's the characteristics of a diesel engine? Characteristics of a diesel engine are compression ignition. Compression ignition. Due to almost adiabatic compression, fuel ignites without any ignition. Initiating apparatus such as spark plugs. Mixture formation inside combustion chamber. Air and fuel are mixed in combustion chamber and not in inlet manifold. Number 1. Compression ignition. Due to almost adiabatic compression, fuel ignites without any ignition. Initiating apparatus such as spark plug. Mixture formation inside combustion chamber. Air and fuel are mixed in the combustion chamber and not in inlet manifold. Torque adjustment solely by mixture quality. Torque adjustment solely by mixture quality, and that is instead of throttling air fuel mixture, amount of torque produced is set solely by mass of injected fuel, always mixed with as much air as possible. Heterogeneous air fuel mixture. Dispersion of air and fuel in combustion chamber is uneven. High air ratio. Due to always running on as much air as possible and not depending on exact mixture of air and fuel, diesel engines have an air-fuel ratio leaner than stoichiometric. lambda V is greater than equal to lambda minimum is greater than equal to 1. Diffusion flame. At combustion oxygen first has to diffuse into flame. At combustion, oxygen first has to diffuse into flame rather than having oxygen and fuel already mixed before combustion, which would result in a pre-mixed flame. Fuel with high ignition performance, as diesel engines solely rely on compression ignition. Fuel with high ignition performance Satani rating is ideal for proper engine operation. Fuel with a good knocking resistance octane rating, namely petrol, is suboptimal for diesel engine. Fuel with high ignition performance, as diesel engines solely rely on compression ignition. Fuel with high ignition performance is ideal for proper engine operation. Fuel with a good knocking resistance, namely petrol, is suboptimal for diesel engine. Cycle of diesel engine. I remember my time when I was studying. This is, I can say, pressure and specific volume curve. I still remember that. Diesel internal combustion engine differs from gasoline powered auto cycle by using highly compressed hot air to ignite fuel rather than using a spark plug. Compression ignition rather than spark ignition. In diesel engine, only air is initially introduced into combustion chamber. Air is then compressed with a compression ratio typically between 15:1 and 23:1. You see, 15:1 and 23:1 air is compressed with. This high compression causes temperature of air to rise. At about top of compression stroke, fuel is injected directly into compressed air. In combustion chamber, this may be into typically toroidal void in top of piston or a pre-chamber, depending upon design of engine. Fuel injector ensures that fuel is broken down into smaller droplets and that fuel is distributed evenly. Heat of compressed air vaporizes fuel from surface of droplets. Vapor is then ignited by heat from compressed air in combustion chamber. Droplets continue to vaporize from their surfaces and burn, getting smaller until all fuel in droplets has been burned. Combustion occurs at substantially constant pressure during initial part of power stroke. Start of vaporization causes a delay before ignition and characteristics diesel knocking sound as vapor reaches ignition temperature and causes an abrupt increase in pressure above piston. When combustion is complete, combustion gases expand as piston descends further. High pressure in cylinder drives piston downward, supplying power to crankshaft, as well as high level of compression allowing combustion to effect without a separate ignition system. A high compression ratio greatly increases engine's efficiency. Increasing compression ratio in spark and ignition engine, where fuel and air are mixed before entry into cylinder, is limited by need to prevent pre-ignition, which would cause engine damage since only air is compressed in a diesel engine and fuel is not introduced into cylinder until shortly before torque gets center. Premature detonation is not a problem and compression ratios are much higher. Now this diagram that is shown is simplified and idealized representation of events involved in diesel engine cycle arranged to illustrate similarly with a Carnot cycle starting at one piston is at bottom. I'll show you that piston is at bottom, dead center, and both valves are closed at start of compression stop. Cylinder contains air at atmospheric pressure between 1 and 2. Air is compressed adiabatically. That's without heat transfer to or from environment. By rising piston, this is only approximately true, since there shall be some heat exchange with cylinder walls. During this compression, volume is reduced, pressure and temperature both rise at slightly before TDC fuel is injected and burns in compressed hot air. Chemical energy is released, and this constitutes an injection of thermal energy, heat into compressed gas. Combustion and heating occurs between 2 and 3. In this interval, pressure remains constant since piston descends and volume increases. Temperature rises as a consequence of energy of combustion. At 3, fuel injection and combustion are complete, and cylinder contains gas at high temperature. And at 2, between 3 and 2, 3 and 4, this hot gas expands. Again, approximately adiabatically, work is done on system to which engine is connected. During this expansion phase, volume of gas rises and its temperature and pressure both fall. At 4, exhaust valve opens and pressure falls abruptly to atmospheric. This is unregistered expansion and no usual work is done. By it, ideally, adiabatic expansion should continue extending line 3-4 to right until pressure falls to that of surrounding air. But loss of efficiency caused by this unregistered expansion is justified by practical difficulties involved in recovering it. Engine would have to be much larger. After opening of exhaust valve, exhaust stroke follows, but this and following induction strokes are not shown on diagram. If shown, they would be represented by a low pressure loop at bottom of diagram. As one, it's at once assumed that exhaust and induction strokes have been completed and cylinder is again filled with air. Piston cylinder system absorbs energy between 1 and 2. This is work needed to compress air in cylinder. Point is provided by mechanical kinetic energy stored in flywheel of engine. Work output is done by piston cylinder combination between 2 and 4. Difference between these two increments of work is indicated work output for cycle and is represented by area enclosed by PV loop. Adiabatic expansion is in higher pressure range than that of compression because gas in cylinder is hotter during expansion than during compression. It's for this reason that loop has a finite area and net output of work during a cycle is positive. Where is that? This is that. Point 1, point 2, point 3, point 4 output. P is pressure, is volume, specific volume. PV diagram for ideal diesel cycle. Cycle follows number 1 to 4, 1 to 4, 1 to 4 here in clockwise direction. Horizontal axis is volume of cylinder. In diesel cycle, combustion occurs at almost constant pressure. On this diagram, work that is generated for each cylinder option to be within the loop. Now see, there's a pressure, there's a volume, specific volume. It goes one. It's isotropic. It's isotropic. Isotropic. This is given 3. Isotropic is for 1 output. Let's say stand on. Efficiency. हाँ क्या करेगी? अभी तो आई है 6:10 हुए हैं, आई है नहीं, टाइम पहले पूछ ले तो चली जाइए। हो कौन रोक रहा है? रोती क्यों रहती है हमेशा? हाँ जब देखो रोती रहती है। हंस के अब क्या? Due to its high compression ratio. Now we are talking of efficiency. Due to its high compression ratio, diesel engine has a high efficiency and lack of throttle valve. Due to its high compression ratio, diesel engine has high efficiency and lack of throttle valve, means that charge exchange losses are fairly low. Charge exchange losses are fairly low, resulting in a low specific fuel consumption, especially in medium and low load situations. This makes the diesel engine very economical. Even though diesel engines have a theoretical efficiency of 75%, in practice it's much lower. So we go further. Major advantages. Diesel engines have several advantages over engines operating on other principles. Diesel engine has highest effective efficiency of all combustion engines. Diesel engines inject fuel directly into combustion chamber, have no intake air restrictions apart from air filters and intake plumbing, and have no intake manifold vacuum to add parasitic load and pumping losses resulting from pistons being pulled downwards against intake system vacuum. Cylinder filling with atmospheric air is aided and volumetric efficiency is increased for same reason. Although fuel efficiency, mass burned per energy produced of a diesel engine drops at lower loads, it doesn't drop quite as fast as that of typical petrol or turbine engine. Let's see if I can save it or no. I forgot I saved it. Let us say save it. Then diesel engine, it's there already, it's no problem. I'll go back to, I'll speak about this later. Now we go back to our paper here. That is here, can say I was talking of its activity. Diesel engines, I think I explained enough on that. We'll talk later on. This engine exhaust fires and overspeeding of engine in live plant area Let's control measures are spark arresters to be fitted to diesel engine exhaust. Shelving valves shall also be fitted where needed. And then we have activity, that is radiography. Mechanical installation, this is radiography. In these hazards are different type. Radiography, control measures, and we have to see that. Site radiography shall only be carried out by competent and experienced radiographers. Radiation testing kit or instruments shall be used by personnel involved on testing. Transport drivers shall also use radiation testing instruments. Site radiography to be carried out in accordance with procedure for site radiography set out in EPC contractors' employers' HSE manual. Local working rules shall be consulted, submitted by NDT contractor prior to work. Area shall be barricaded by embankments on site for open performance. Embankment shall be higher to diminish radiations. Material storage pits, say 1 to 1.5 meter deep, shall be constructed to avoid unauthorized access. Emergency equipment, namely local shielding, sandbags, tongs, etc., to be provided on site. Warning signs, barriers, flashing lights, alarms, etc., to be provided. Trifolio warning signs shall show RPO address, telephone, and location. Radiation meters to be calibrated and certification obtained. Contractors' personnel located in adjacent working area and security staff to be notified in advance. General notification respecting radiations to be circulated to all. This is, of course, we discussed before about radiography. Site radiography shall only be carried out by competent and experienced persons. Very important. We discussed about this before also. This before also, and let me see what this says about this. Diesel engine is something special. Fuel injection will see controlling. We'll see later on now. We'll see this later on because it's a long file. And let's say I had some before. I had some radiography file in this, if I can remember. I had some radiography file. I can come back into that. Management documents. This is HSE, and that's HSE procedures, and radiography file is there something I don't know. Let's say grinding, hazards control, hazard safety, working, hoisting, rigging, and for radiation workers, measuring radiations. So it was information for radiation workers. It was, yes, I remember. It was this one. This was information of radiation workers. That was his information. It was the, I think you remember that those radiation workers, those history database, radiation workers, etc. It was, and we had something about that. And also then it was another one case of radiation, that is radiation workers, and that's radiation, measuring radiations. It was. And that is about measuring radiations in this case. It is also same, we remembered. We can discuss this later also again, because it's not, I can't do it now. We'll see how it works. So we are saying we have gone through this. Now we'll go to another one. That is activity is pressure testing. Hazards, pressure testing, and it's bursting of blinds, pipes, fittings under pressure testing. Control measures. This is bursting of blinds, pipes, fittings under pressure testing. So it is, you can say, pressure testing we're talking of here. Bursting of this hazard is bursting of blinds, pipes, fittings under pressure testing. Pressure testing of piping shall only be carried out by competent and experienced personnel. It's everywhere in every activity. Pipe work on the test and surrounding area to be barricaded, cordoned off, and suitable warning signs displayed. Non-testing related personnel shall be instructed not to enter areas where pressure testing is being conducted. A written procedure for gradual pressurization to be developed. All fittings, namely sight glasses, gauges, bursting discs, likely to fail under pressure testing, to be removed. This is very, very common. That is pressure testing. And if we just try to find out from here, we can say we'll put it off. Pressure testing, Google. Oh no, this is not that. Or something else it is. It's not that one. Sorry, this is wrong. Hydraulic. Pipe pressure testing. Pipe pressure testing, I would say. Let's see it's coming in. Pipe pressure testing. Response services maintained. I'll see it later. It's not coming into my consideration. It's not right. So I'll see it later on. Okay, we go first. Then we'll see cable drum handling. Cable drum handling. Hazard is cable drum falling, trapping injuries. There's hazards and there's drum falling, cable drum falling, trapping injuries. Measures of damaged cable drums not to be used. Vehicles to be located suitably with regard to site traffic and area for offloading to be barricaded off. Cable drums to be offloaded using slings of an adequate strength to sustain workload safely. This operation is to be carried out by experienced and competent personnel. Cable jacks to be placed on even surfaces. Cable drums shall be located on cable jacks of suitable capacity and base designed for this purpose. Protruding nails on cable drums to be removed, bent over. Cable drums to be checked when stored. So what you say here is cable drum falling is another, trapping injury is another one. So it says damaged cable drums not to be used. That's one point of measure. Vehicles to be located suitably with regard to site traffic and area for offloading to be barricaded off. Cable drums to be offloaded using slings of an adequate strength to sustain working load safely. This operation is to be carried out by experienced and competent personnel. Cable jacks to be placed on even surfaces. Cable drums shall be located on cable jacks of suitable capacity and base designed for this purpose. Protruding nails on cable drums to be removed, bent over. Cable drums to be checked when stored. Cable jacks. Let us see what it says about that. Cable jacks. Okay, that's one point here. I'll show you what's that actually. It's better. Can't you like that term is that? It's an image actually. Problem is that's an image. Let's say if we can do something on this, or I can show you as print. This is that. This is, bolstered by this. This is that one. This is jacks, cable drums. What we're talking about is this. So, cable jacks to be placed on even surfaces. Cable drums shall be located on cable jacks of suitable capacity and base designed for this purpose. Rotating nails on cable drums to be removed, bent over. Cable drums to be jacked when installed, and that is this one. You can see cable drum. And we have to go further on electrical installation. This was of electrical installation as well. I cannot say it's not electrical installation, it is. So this is also another one. It says hazards, cable pulling. Let's think of cable pulling. It says cable pulling. Cable pulling. Here you can see here. So that let's say you can print that one. Yes, how can I print this? It's not going to print. Let's say if I can print this way. No, not that way. No, it's not taking. I think there's something wrong here. It's not helping. Print is here, yes. So we can say I'm going to print it. So it's that. this I think this should be on there. Yes, sir. Yeah. Yes, sir. This is we can say here cable. This is cable pulling. So these two we have here. So we can say cable drum falling the first, and that was in first case the hazard was cable drum falling. Cable pulling is cable drum falling. Trapping injuries, manual handling, back injuries. So these are hazards. Cable drum can fall. Trapping injuries and manual handling, back injuries happen. Control measures are personal to wear suitable gloves, footwear when cable pulling is ongoing. Cable jacks to be of sufficient capacity and placed on an even surface. Personnel shall be instructed in cable pulling techniques, methods including requirements for ensuring good manual handling, methods as well as when so adopted. Assessment of weight of cable to be pulled and numbers of persons required to be defined depending on cable weight calculation assessed. And this is of cable pulling. Let's say this is gone. It also says the basics of cable pulling. So we have here what you say is this interesting one here. You can see this diagram. This is photo also of cable. This cable pulling. You can use both for your work. And here is say in cable pulling, hazards are cable drum falling, trapping injuries, manual handling, back injuries. Personal to wear suitable gloves, footwear when cable pulling is ongoing. Cable jacks to be sufficient capacity and places on an even surface. Personnel shall be instructed in cable pulling techniques, methods including requirement for ensuring good manual handling, methods as well when so adopted. Assessment of weight of cable to be pulled and numbers of persons required to be defined depending on cable weight calculated. Hazards analysis programs. This is for cable laying, cable termination. We'll see how it can be taken. Start. Well, I think it is now size cable drum filling and says cable laying, cable termination. Cable drum falling, trapping injuries, manual handling, back injuries, and measures are person to wear suitable gloves, footwear when cable laying, termination cables, cable jacks to be of sufficient capacity and should be placed on an even surface. Warning signs to be positioned adjacent to cable laying, cable termination areas. Persons shall be trained in cable laying, cable termination techniques, including persons shall be including requirements for ensuring good manual handling, methods as well as when so adopted. Cable termination shall be carried out by trained and competent personnel using suitable tools. Permits to work systems to be followed to ensure that glands and terminals of cables are on electrically isolated panels. Then it is material handling. was said is true to best of this, and will now take, I think it's time to go. Well, it's only 3:06. What else I see? I can go and see. Again, I see this is cable drum, this is cable pulling, and this is your run. This is quality pile. This is lesson, and I can say, let me see what's left in this. We'll see this. This will see hazards, cable drum falling. We'll see 812 it is. Let's say there will be more for the more here. Many more, still more. It will take time. We have to explain each and every one. So I'll put off some files now for gone. And let's keep this off as well, and we'll see. I think should close it now, right? It's really sometimes very difficult, but understandably good that we should try to do as much as possible. We should extract as much as information possible. That sources available nowadays. It's internet, some information, it's your experience information. It's all important to understand, to have more coverage of what you can get. It's really one interesting one. How to get it, how not to get it. It's very much interesting. We can get it right now. So I say, we should now close it.